At some point, we're actually going to want to deal with the question. We want to actually answer the question presented in a particular scenario. Now, we've already talked about how to make the meaningful sketch. Now it's time to publish your motion model. Now, what do I mean by that? So let's talk about that. Because it's the motion model that's actually going to answer the question for you. Okay, so what do I mean by publish? Well, what do I mean by motion model? Let's talk about that. A motion model is a position equation for each object moving, doing something in your scenario. If you have one object, you'll have one position equation. If you have three objects, you'll have three different equations, etc. Okay, so what is a position equation? A position equation is going to be in the form of the following, because what I'm writing here is actually not a position equation. It's the template for a position equation. So this is your final position or future position at some later time t equals the velocity, which is a vector, so this is going to have plus or minus in it, and then times time plus where your object started from. If you want to use a different, let's see, nomenclature style, I'm drawing a blank here. Anyway, if you want to do it the other way, you can say x final equals v sub t plus x initial. These are synonyms, something like that. Okay, so now let's go ahead and do it. Let's show you what. Oh, and what do I mean by publish? I mean make it fancy, make it complete. Okay, what am I really saying? You need units. That's what I'm really saying. You need units for every constant. This is going to be a constant. This is going to be a constant. All right, let's make our motion model for the Beebe scenario. Okay, so I'm going to have three position equations, and I'll just go in order. We're going to have xm, xj, and xb, x sub m. Okay, so I tend to use subscripts. I think, well, how else? You've got to basically, how do I distinguish between the monster's position, Justin's position, and Beebe's position? So subscripts is the way to go. Okay, equals. All right, let's do the monster. Okay, velocity times initial position. Okay, so velocity, 6 meters per second, but going in the negative direction. That's super important. Velocity is a vector. Okay, am I going to worry about sig figs? No. Okay, times t, and now what is its position? Plus 195 meters. That is, okay, maybe it doesn't look fancy, but it certainly is complete and it has units. So that is a good position equation. What about for Beebe's? Okay, Beebe's is Beebe's is going positive 15 meters per second times t, and what is his initial position? Plus 75 meters. Okay, units, complete. Okay, and then the busload of adoring teacher fans is going positive 22 meters per second. Remember the units times t, and plus it starts at the origin, so we don't write that. This is the motion model for the example scenario we've been working through.